Okay, so here's another problem about power. I'm going to assume you already remember our power equation from before. But what we need to do is make sure we know what our, sorry, let me erase these marks there. Make sure we know what our information from the question is. So that's what these three numbers here are. So 80 kilograms, that's talking about mass. 15 meters, that's talking about our height, or what I'm going to call, in this particular problem, our change in height, and you'll see why I'm going to do that in a minute. And then 2 seconds, that's delta t, that's our time. Okay, so that was pretty easy. So in our last question, when we were talking about work, we said work is force times distance, or force times change in position, which is F times delta x, which is true. And we could use that again and do this problem pretty similarly to how we did the other one. But I'm going to show you another way so that you have more than one way to do the problem and you can choose which way you like more. And that's going to be using our other definition of work. So what is that other definition of work? So work equals the change in energy. So basically what I'm going to do now is take this definition of work and I'm going to plug it in over here. Okay, except I'm going to erase that because that arrow is going to be in my way. But basically I'm going to take that definition of work that involves energy and I'm going to write it in my equation here. So, sorry, that's a sloppy W. So this means this is the change in energy divided by change in time. Well, now think about this. What kinds of energy have we talked about? We had kinetic energy, which was for things that were moving and kind of how much energy was involved with that. And then we had potential energy that had to do with, the height and the mass and that kind of thing. So for this question here, let's start with looking at kinetic energy. Am I wondering how much power did it take to get going a certain speed, or just how much power it took to move? And it says how far we moved and how long. So you might be thinking about velocity, but really what I care about is, how much power did it take to move up 15 meters in 2 seconds? So we don't want to use kinetic energy. We want to use potential energy, which is most of the time, well, maybe I shouldn't say that. For this question anyways, we're going to be using potential energy from gravity. Okay, so let's make sure we remember what that equation is. So what is that equation for potential energy from gravity? Hopefully you remember it depends on the mass and gravity's acceleration and h, which is the height. Or some of you might have seen or might have used a little bit different version, which is mg delta h. And so that just means the change in height. And that's why I chose to write my 15 meters as the change in height, because really that's what I want to know is how much did my energy change, because that's what work is, and we're trying to figure out how much work and how much time. So we have all that. Now it's time to start plugging things in. So let's go back to red here. Okay, so I'm going to rewrite this equation using what we know. So this is going to be potential energy, or sorry, power. This P is for power, equals my change in energy, but my change in energy is just my change in gravitational energy. So that's this mg delta h. mg delta h divided by delta t. Okay, so now we can start plugging things in. So I know from my word problem that m equals 80 kilograms. So that's 80 kg. Put that in parentheses. All right, g. What is g? We've used g a bunch before. We know that g is 9 9.8 meters per second squared. You might have been tempted to put a negative in there, which is fine. All that negative means is that it's pointing down. Gravity's pulling down, but we already knew that, and it will save us a little bit of trouble if we don't worry about the negative right now. So let's plug in 9.8 for G. So there's 9.8 meters per second squared. Okay, now delta H we know is 15 meters. And delta T, we also know from the word problem, that is 2 seconds. Okay, so now to solve all this, we're just going to punch it in our calculator. So I'll pull up my calculator here, and this says, so 80, so that's 80 times 9.8 times 15. So the top is 11,760. I'm going to divide that by the bottom, which is 2. And so that equals 5880. So got kind of a slanted equal sign there. So we get 5880. And what is our unit for power? We have to think back to our last question, our last couple videos. We know that power comes in units of watts, which is a capital W. Okay, so that's the answer for our first part. That's how much power do his legs have, 5,880 watts. But we have to figure out how to answer this. How many horsepower is this? You may also remember that 1 horsepower, 1 HP, equals 745 watts. So what I need to do now is I take this 5880, so I'll write that, 5880, and that's watts, and I want to change it into horsepower. So what I'm going to do is I'm going to do a little multiplication thing here, and this is why I'm showing you guys this, because we've done things like this a couple times in class, but hasn't been super clear. So I have watts on the top over here. That means I want to take this number with the watts, 745 watts, and that's going to go on the bottom. So I'm going to put 745 watts on the bottom. And you mean on the bottom of what? Oh, sorry, I should have drawn my fraction first. There we go. So we're making a fraction. So 1 horsepower goes on the top. And so now we're going to find out how many horsepower this is. And I made these numbers up, so this might not be very accurate. So equals, now we'll go over here. So we still have our 5,880. Now we're just going to multiply by 1 divided by 745, which is actually just the same as dividing by 745. And we get 7.9 horsepower. Well, 7.89. We're going to round that to 7.9 horsepower. So is that realistic? Obviously, my legs are not as strong as 7.9 horses, but horsepower is not really, I don't know, it's not a very good, it's a fine unit to measure things, but it is not exactly, like 1 horse might be more than 1 horsepower. So as far as our math is concerned, everything is right. If you want to debate how strong my legs are, then that's another question. So what I'm going to do is just put a box around my 2 answers here so that it's easy for someone to find the final answers. And that's basically how you do that kind of problem there.